Good morning and welcome to Computer Science 311, Data Structures and Algorithms. Continuing on with our discussion from Chapter 2, Analysis of Algorithms and Elementary Sorting Algorithms. We're going to talk about the three different elementary sorting algorithms. We've already mentioned the insertion sort, and we'll do it again very quickly. But then there's also selection sort and exchange sort. For this example, I want to assume that I have this array over here. It's an array of 5 integers, 23, 14, 87, 5, 16. This is an array of 5 integers, so it goes from 0 to 4, the indexes. I want to assume that n is equal to 5. This n will come in when we do our analysis of algorithms. So if n is equal to 5, n minus 1 is the index of the highest index in the array. So let's go through some review of insertion sort. So here is our original array, and you may remember that we wrote this method here. We had something that we called the insertion loop. And what the assumption here is that the subarray from 0 to 0, which is just this one element here, this is already sorted. So what we need to do is we're going to use the insertion loop to insert the 14 into this already sorted array that just has one element in it. So when we're done with that, it's pretty clear that the array that would result would look like this. There would be a 14 here, there would be a 23 here, then again there would be 87, 5, and 16. And we note, whereas before we just had this as our sorted subarray, everything north of that, now these two elements are sorted. And now what we're going to do again is we're going to execute the insertion loop to insert 87 into this sorted subarray. Well, this is one of those cases where 87 is already where it belongs. So we have now the situation. So now I have a 14, and I have a 23, and I have an 87. And now I note that this is sorted, and then I have a 5 and a 16. And now I'm going to do the insertion loop again. I'm just going to call it the IL. And I come over here. And now I have 14, 23, 80. Whoops! Made a mistake here, so let's go ahead and erase. Why don't we note what my mistake was? The mistake is that I want to insert 5 into this sorted subarray. So let's erase that. Okay, so if I'm inserting 5 into this sorted subarray, that's going to put a 5 here, and then it's going to put a 14 there, and then it's going to put a 23 there, and it's going to put an 87 there, and a 16, and I'm like that, and I've got to do the insertion loop one more time. And when I do that, it's going to come up here, and I'm inserting 16 into this sorted subarray. So it's going to be 5, 14, 16, 23, and 87. And now I'm done. And here's the thing to note. Note that I did the insertion loop 1, 2, 3, 4. So if there are n elements in the array, we call the insertion loop n minus 1 times. Okay, and we will return to this in a moment. Okay, so how does the selection sort work? The selection sort works by the following. It says what I want to do here is I want to scan through the entire array and I want to find the address of the smallest element. Now in this case, the smallest element occurs right over here at 3. Remember, this is 4, 2, 1, 0. And what I want to do is I want to swap these two things here. So what I'm going to call this is I'm going to call this the find min loop. And what's going to happen here is as I come over here, now it may occur that the minimum is over here at 0, in which case I don't have to do anything. But in this case I do. I'm going to swap these two elements. I'm going to put 5 over here, and I'm going to come over here and I'm going to put 23 over here, and everything else remains the same. But the thing I note is now the smallest element is right where it should be. Okay, so now what I'm going to do is I'm going to do the find min again, but now I'm only going to do it on this subarray right here. Now when I do that, it turns out the minimum is right over here, so there's nothing to move, but I'm going to have 5, 14, 87, 23, 16, and I note that I now have the two smallest elements over here. So now what I'm going to do is I'm going to do a find min over here. So I come over here and I'm going to say find min, and when I do that, I find the minimum. Okay, the minimum here now occurs here, so I'm going to swap these two. So I'm going to put the 16 here. I'm going to put the 87 here. Okay, this is still 5, 14. This is going to be a 23. And now I note that I am okay up to this point right here. And now what I'm going to do again is I'm going to do a find min. Okay, and I notice over here the minimum is already there, so I don't have to do anything. So I've got 5, 14, 16, 23. Okay, and I note that these are all in order, 87. And of course at this point I'm done. I don't need to do this anymore. Okay, so this array is now sorted. And I want you to note that I called find min 1, 2, 3, 4. So again, I want to make this, the statement here. If there are n elements in the array, what I do is I call find min n minus 1 times. And I hope that's clear. And these two observations over here, notice that I did these n minus 1 times. So first of all, even structurally, as we think about how we're going to write the code for insertion sort or selection sort, you can see that I'm going to have an outer loop that is going to execute n minus 1 times, and I have an inner loop where things are going to get smaller and smaller, and we'll discuss the inner loop in a minute. Now exchange, we're going to have to do something a little bit differently here. Exchange, and some of you may recall, exchange is the fancy name for bubble sort. Bubble sort is a very cute name indeed. And in fact, what we're going to do over here is The way that it works is I start at the bottom of the array and I compare these two elements here. And if those two elements are already in order, I leave it alone. And if they're not in order, then I need to go ahead and swap them. So what's going to happen is I'm going to come over here, and just to make people happy, I'm going to call this bubble up. And in this particular case, okay, we're going to see that it's still 5 and 16, and the rest of the array is left alone, 14, 23. Now what I'm going to do is I'm going to compare these two elements over here, and if they're out of order, I'm going to go ahead and swap them. So what happens is, and again I'm going to call this bubble up, BU. And in this case, I'm going to get 16. And over here, I'm going to get a 5 and an 87. And these guys over here are going to be left the same. So that's a 14 and a 23. And now what's going to happen is I'm going to compare these two elements. I'm going to do a bubble up. Okay, and what's going to happen here is I'm going to get 5, 14, 87, 16, 23. And finally what I'm going to do over here is compare those two, and I'm going to swap them, and that's going to get me 5, 23, 14, 87, and 16. Now the point is, this is not a sorted array, but the point is I now have the smallest element is now over here, okay? And what I need to do is this whole bubble up process, I need to do it again, but I don't need to go all the way to the top of the array. I only need to go up to here, okay? So I think you can see I'm going to go through it on the completely uninitialized array. I start at the bottom and go all the way to the top. The next time through it, I'm only going to go up this high. The next time up, I'm only going to go up this high. And the next time up, I'm only going to go up this high. So if there are n elements, I'm going to call bubble up n minus 1 times. Okay, so I hope you're starting to see a pattern here in all of these. And all of these, what we're going to do is we're going to break these up into pieces. We're going to write insertion loop, we're going to write find min, we're going to write bubble up, and we're going to see that we need to stick them inside a loop that executes n minus 1 times. Easy? Okay. Let's consider this. I'm going to move this over. We need some more paper. Here it is right here. Okay, so let's do the insertion loop. Well, we've already written the insertion loop. Okay, so the insertion loop, again, if you recall, let me get this out of the way. Okay, the insertion loop says that we come over here and we do something like the following. We say let temp equal AR of K. Then what happens is we come over here and we say something like the following. For J equals K minus 1. Well, J is greater than or equal to 0. And we go J minus minus. we come in here and we say the following. If ARJ is less than temp, it's time to get out of there. Otherwise, what we want to do is we want to do and I'm going to leave a blank line here for a second, and I'm going to come down here. And then we said that what we would do down here is we would say something like the following, that AR of J plus 1 is equal to temp. Okay? And you should all recognize this. We have written this before. And all we need to do to make this a full-fledged sorting loop, this is the insertion loop. So the insertion sort would look something like the following. So remember when we were over here, the first time, this would be k is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4. Did everyone follow that? In other words, over here, we want to insert AR of 1 into the sorted array that starts at AR of 0 and ends at AR of 0. Here we wanted to insert AR of 2 into the sorted array that started at AR of 0 and went to AR of 1. So this would be k equals 1, k equals 2, k equals 3, k equals 4. So we want to go for k equals 1, well, k is less than or equal to 4. Is that right? This is k is 1. K is 1 got us there. K is 2 got us there. K is 3 got us there. And then finally k is 4 got us there. So yes, we want to go all the way up to k is 4. We want to do this. Okay? That is the insertion loop. And now I want to go ahead and I want to analyze this mathematically. And I'm going to do this in a really easy way. Remember I said over here, leave this blank. Now, normally we wouldn't stick this in a sorting algorithm, but I'm going to come over here and I'm going to say system.out.println. Hello. And the question that I have, notice that the system.out.println is buried deep inside, okay? It's inside of this inner for loop. And the question I have is that in the worst case scenario, how many times is hello printed out? Okay? Well, think about it. If k is 1, it's going to come in here, and this loop in here, if k is 1, this is going to go from j equals 0 while j is greater than or equal to 0. So in the worst case scenario, it's going to print it out 1 time. Then what happens is I come back up to here, and now k is equal to 2. So this loop on the inside is now going to go from j equals 1 while j is greater than or equal to 0. Well, that's going to be for 0 and 1. So hello would be printed out 2 times. Now I'm going to come back up here, okay, and now k is equal to 3, and now what's going to happen is this is going to be for j is equal to 2 while j is greater than or equal to 0, so that's going to be for 2, 1, and 0. Hello is going to be printed out 3 times. And then I'm going to come back up here, and k is equal to 4, okay, so I'm going to come right down here, and I'm going to have for j is equal to 3 while j is greater than or equal to 0. Well, that's going to be for 3, 2, 1, and 0. That's 4 times. Okay? So what we have to do here is we have to add these numbers up. Now in this particular case, that's 7, 8, 9, 10. But I said, suppose we have n elements. Suppose we have n elements. Okay, then big O of n is equal to 1 plus 2 plus 3 plus n minus 1. And you may recall from the last video that that is equal to n minus 1 times n over 2, which is equal to n squared over 2 minus n over 2. But then that says to me that big O of n is equal to n squared. Remember, we just are interested in the term with the highest exponent. So this is the result that we're looking for here. Okay, so that's one sort down. Now let's take a look at selection sort. And remember, for selection sort, we said we need to write this method here called find min. And remember, what I'm trying to do is I'm not trying to find the minimum value. I'm trying to find the address of the minimum value. And here, so what I want to do, just to make things easy, I'm going to write this as a separate function. But you can see over here, what sorts of parameters do I need to give to the function? Well, I need to pass to it the integer array. I need to pass to it the starting address. And I need to specify to it the ending address. In other words, just think about it this way. What I want to do is I want to write a function, and I want to be able to specify to the function an arbitrary array. Maybe this goes up from 0 up to, I don't know, 3,000. But I want to have start and I want to have stop, okay, which would correspond to these indexes right here. And what I want to do is I want to find the address of the smallest element contained in there. So I might come over here, so I might say something like, I might declare int min address, and I might later on in my program come in here and say min address is equal to find min in the array AR from start to stop. And I'm going to come over here and maybe I will have in start and stop. So it's going to look something like this. And then you can imagine that I would use that thing to swap it. Okay, so the first thing I want to do is I want to write this one here. And that's not going to be too difficult. I'm going to come over here. It's a return type of int. And I'm going to say int find min. And I'm going to come in with an integer array. And I'll call it nums. And I'm going to call it int begin. And I'll call it int end. Okay, and this algorithm is pretty simple. What I'm going to do is I'm going to come in here. I'm going to have int low address, and I'm going to let that equal to begin. And the thing to remember here is what I'm going to do at the end is I'm going to return low address. Now, the idea here is actually pretty simple. So suppose this looks something like this. Suppose this is 0, 1, 2, 3, 4, 5. Suppose I'm working on this whole thing. What I would do is I would come in here and I would assign low address to 0. And then what I would do is I would start at 1 and I would go through the whole array. And if I found an element that was less than low address, then I would reassign low address. So I come through here and I go, is 89 less than 23? And the answer is no. So low address is still at 0. And I would come over here and I would go, is 4 less than 23? And the answer is yes. So I would let low address now be 2. Is low address, is this less than what is pointed to by low address? The answer is no. Here, no. Here, no. So I would then return the value 2. So in fact, what I'm going to do over here to make things easier, I've got low address, and I'm going to have int low val. I'm going to let that equal nums of low address. And now what I'm going to have in here is I'm going to have a very simple loop int j. I'm going to come in here and I'm going to say for j is equal to, well, I'm going to, let's see, I'm going to let it start at begin plus 1. And then I'm going to say, well, j is less than or equal to end. And then I'm going to say j plus plus. Okay, and then I'm just going to come in here and I'm going to say the following. If, okay, nums of j, if that's actually less than the low value, then, this is terrible, I should have had some more space here, then what I'm going to do is I'm going to let the low value equal nums of j, and then what I'm going to do is I am going to let the low address equal j. And that looks so bad that I am going to rewrite this for you. So let me clean this screen up a little bit for you. At least it's going to help us. I'm going to come over here and I am going to say int find min, and I am going to have int nums, int begin, int end, and what I'm going to do is I'm going to come in here and I'm going to have int low address equals begin. I'm going to have int low value equals nums at begin. So keep note of what I'm doing here. I'm keeping track of where the smallest element is, and I'm keeping note of the value of the smallest element. Okay? Then I'm going to come in here, I'm going to have int j That's just a loop counter. And now I'm going to say for j is equal to begin plus 1, while j is less than or equal to end, and I'm going to say j plus plus, and then I'm going to say in here if nums of j is less than the low value, then what I need to do is I need to say that low address is equal to j, and I need to say that low value is equal to nums of j. And then I close that up. Okay, and let's see, that is the end of my for loop. My for loop just has one statement in it, so I don't need brackets here. But you know something? I'm going to put brackets in here, and you'll see why in a second. And then I'm going to come over here and I'm going to say return low address. I'm going to close this up. Okay, so that is my find min. And again, if we go back to selection sort, over here, you can see that if I have n elements in the array, here I'm calling, in this case over here, I would find min from 0 to 1. Here I'd find it from 0 to 2. Is that correct? No. In here, I would find the minimum between 0 and 4. Okay, then I would find the minimum between 1 and 4. I'd find the minimum between 2 and 4. I'd find the minimum between 3 and 4. Okay? No need to find it between 4 and 4. So that if we were going to make this now into the actual selection sort, I would come over here and selection sort would look like the following. So remember what's going on in here. Here I need to find the minimum between 0 and 4, between 1 and 4, between 2 and 4, between 3 and 4. So I basically need to have a loop that's going to look like this. For k is equal to 0, or k is less than n minus 1, k plus plus, and then what I need to do is I need to come over here and I need to say something like the following. The min location is equal to, let's see, we called it find min from k to n minus 1 in the array AR. No, I did this in the wrong order, didn't I? We have to erase. 1,000 pardons. In AR, starting at k and going all the way up to n minus 1. And then we would come over here and we would say if minloc doesn't equal k, what does that mean we need to do? It means we need to swap the elements. So we come over here and we say temp is equal to AR of k. AR of k is equal to AR of minloc. And AR of minloc is equal to temp. And that is all of selection sort right over there. So now the question is what is the complexity of this algorithm? And again, we have find min, and you'll notice that I left a space in here. And the reason why I left a space in here is again, I asked the question, suppose I were to say system.out.println hello, and the question I have is how many times will hello be printed out here? Okay, so let's analyze this algorithm. Okay, so for selection sort, we notice that we're calling find min. Okay, the first time we call it, we go from 0 up to n minus 1. If we're calling it from 0 up to n minus 1, you can see that what's going to happen over here is we would print out hello n times. The second time through the loop, we are calling minloc, and instead of starting at 0, we're starting at 1. So we're going from 1 to n minus 1. So whereas the first time through it, we printed hello n times, this is going to print it n minus 1 times. Then what's going to happen is the next time through it, we're going to print it n minus 2 times. Okay? And this goes all the way up to n. Okay, so it says k less than n minus 1. Okay, so that would be the biggest it's going to get is n minus 2. So the very last time we're going to do it from n minus 2 to n minus 1, it's going to print it out n times. Or I'm sorry, it's going to print it out 2 times. We're going from n minus 2 to n minus 1. So what's happening over here is the number of times we're going to print out hello is going to be n plus n minus 1 plus n minus 2 plus all the way down to 2 times. Okay? So the question is what is this number? And the answer is I'm not quite sure, but I do know this one, n plus n minus 1 plus 2 plus 1, that is equal to n times n plus 1 over 2. So this quantity over here must be equal to n times n plus 1 divided by 2. Okay, and what I need to do is to get this to here, I just need to subtract 1. So this is equal to n squared over 2, okay, plus n over 2 minus 1. And again, we will notice that the big exponent here is right over here. So we would say over here that big O of n is equal to n squared. Okay, finally, we need to do our last analysis here. We need to write the code and also take a look at the complexity of the algorithm. I think you probably all could guess what the answer will be. But it's this thing called exchange sort. And we saw that exchange sort is made up by repetitive calls to this function that we're calling bubble up. Now we can see that bubble up, the very first time we go through bubble up, and this is just one call of bubble up right here, we've got to start at the very bottom and we've got to go all the way up to the top of the array. The last comparison would be the top 2 elements of the array. So we can imagine over here it's going to be a void method. We're going to pass to it the integer array. We're going to pass to it where in the bottom to start and where in the top to stop. Okay? And this should be pretty clear the way this code works. I have a loop counter here. I start at the bottom. In this case, it would be 0, 1, 2, 3, 4. So in this case, in this particular invocation here, I would want it to go from 4 down to 1. Okay? So what I do is I compare 2 adjacent elements. If the one with the bigger index is smaller, I need to swap them. Okay, so this particular picture, the sequence of pictures that you see over here, would be accomplished by calling bubble up, where I started bottom at 4 and I stopped it at 1. And when I'm done with this, this would say to me that I've got the smallest element is now up in the 0th element. So now, to make this into the complete sort, what I need to do, again, we go back to the picture over here, we can see over here that, again, you can see just by following this logic over here, I'm going to do this n minus 1 times. And what I want to do each time is I want to basically chop off the top, if you will. So we could imagine that the code is going to look something like the following. And I want to be careful of my indices here. So there's bubble up. So I'm going to come over here and I'm going to say for k equals 1, while k is less than or equal to n minus 1, k plus plus, okay? And then what I'm going to do over here is I'm going to say bubble up, and I have to, let's see, according to bubble up, I'll put this code right underneath here. I have to pass it the array, AR, and over here I am going to give it the bottom. So the bottom is always going to be at n minus 1, and the top is going to be k. And that's really it. This is the whole, this is exchange sort right here. Right there. And the question is how many times is hello going to be printed out? Okay, so in this case over here, the first time through, it looks like it's going to be printed out n minus 1 times. And then the next time through, it's going to be n minus 2 times, n minus 3 times, and finally, it's going to print out 1 time. So I come over here, and if I want to sum up the first n minus 1 integers, that is equal to n times, nope, that's incorrect. This is 1 plus 2 plus 3 up to n. What I want to do is 1 plus 2 plus 3 up to n minus 1. So what I need to redo is replace all of these n's with n minus 1s. That's going to give me n minus 1 times n over 2, which is equal to n squared over 2 minus n over 2. And again, we note that's the largest exponent. So I get big O of n is equal to n squared. And we are done for all 3 sorts. We noticed that all 3 sorts had complexity of n squared. Those are referred to as the elementary sorts.